I'm Anil Kumar. In this video, I'll share solution of 8 questions, word problems based on distance, speed and time. So this has been given to me from my student Ramandeep, who wants to understand how to solve these linear system questions where we have to define two variables and then solve for both of them. So we have 7 questions from this worksheet. We'll take them one by one. We also have answers for these, right? So you can actually note the answers. You can copy these questions, pause the video, copy the questions, and then try them out one by one. We'll take them now. Beginning with question number 1. To start with, I'll tell you a lot of concepts all in question number 1, and then we'll rather move faster so that we can do them very easily. So as you practice with me, you will be perfect in solving any question like this. We are not going to use calculator to solve, as in some tests calculator may not be allowed. Question number 1. It took Terry 7 hours to drive 390 kilometers from Cold Bay to Morgan's Cave. He averaged 60 kilometers per hour for the first part of the trip, but was forced to complete the trip at 50 kilometers per hour due to a thunderstorm. How many hours did he spend driving at 50 kilometers per hour? You have to take care of two things. One, you should know the relation between distance, speed and time. I'll put this with the help of a triangle, easy for you to remember. Distance is speed into time. So that's the triangle. Next, I will also use a table to display all the information given to us. So my tables will be like this. All tables are exactly same, right? So we'll have here distance, speed and time, right? So we're talking about two equations. We'll divide it into two portions. At the end, we'll write the total, right? So that is how I'm going to make my tables. I'll write distance, speed and time in each. These will be two different conditions which will give me two equations, and the last column is for total. Okay, so let us see how to fill this up. So it says it took Terry 7 hours to drive 390 kilometers. So first thing is units. So distance is kilometers, speed is kilometers per hour, and time is in hours. Correct? From Cold Bay to Morgan's Cave. So total time is given to us. Terry took 7 hours to drive. So time total is given, which is 7 hours. Do you see that? Total distance is given, which is 390. So we'll write 390 here. Distance total. Right? He averaged 60 kilometers per hour for the first part. So we're talking about two things, which is first and second part. He averaged 60 kilometers per hour for the first part. So that is the speed. Kilometers per hour is 60. But was forced to complete the trip at 50 kilometers per hour due to thunderstorm. So next phase, only 50 kilometers per hour. How many hours did he drive? So we need to find what? How many hours did he spend driving at 50 kilometers per hour? So we need to find this. Do you get the idea? So I hope the table is absolutely clear. All the information has been placed. All tables for all 8 questions will be like this. Okay, so as we move along, it'll be very easy for you. Now look here. Since we want to find this, we start with a let statement. So it says, how many hours did he spend driving at 50 kilometers per hour? So we'll say let T be time for 50 kilometers per hour speed. Is that okay? So we are writing this as time t. This is the variable which we have defined. Is it okay? Now, if t is for the second phase, what is for the first phase? Total is 7. So you could do it in single variable or you could do it with two variables. Now we'll say since total time is 7, so time for first part, which is at 60 kilometers per hour. So I'm writing this just to explain you, is how much? If this is t, total is 7, this has to be 7 minus t. Does it make sense to you? So time for the first part is how much? Is 7 minus t, correct? Is 7 minus t. So we know that is the time. Now we know that the total distance is 390. Now how do you find distance when speed and time is given to you? From this formula, we know distance is speed into time. You have to just multiply them. Is it okay? So I could write here distance as 60 times 7 minus t, right? So this column here will be distance, which is 60 times 7 minus t. And here the distance will be 50 times t. And when you add these up, you should get 390. Does it make sense to you? So we get our equation, which is 60 times 7 minus t plus 50 times t is equals to total distance of 390. So this particular question we have actually solved using only one variable. In the next similar question, we'll use two variables. Now it is question of simplifying it. So first step is you could divide all the numbers by 10, right? So first step we can simply divide by 10. Everything, is it okay? Then what do you get? You get 6 times 7 minus t plus 5t equals to 39, correct? Open the bracket. 6 times 7 is 42 minus 6t plus 5t equals to 39. Bring constants to one side, variables to the other. So we have 42 minus 39 equals to, bring them to the other side. So we have 6t minus 5t, correct? 6t minus 5t is t, and 42 minus 39 is 3, correct? So we get the value of t here, which is 3, and you have to include units, which is hours. Do you get the answer? So now you can write down answer. Word problems, you have to write the complete statement. How many hours did he spend driving at 50 kilometers per hour? You say he spent 3 hours driving at 50 kilometers per hour, right? So in this particular example, go through it once again, see how we did everything, correct? And then let's move to the next example. Question number 2. We'll follow exactly same pattern. So just so that you become very familiar to it. So we will make this triangle relating distance, speed and time. So whenever you're working on distance, speed, time, make this triangle, and then we'll make a table. So even before reading the question, I know it's distance, speed, time. I'm kind of making my table. Okay, so this is my table. Dividing it into two parts because there are two conditions, and this is my total. Is it okay? Correct. Now let's read the question. Question number 2. When a plane flies into the wind, it can travel 3000 kilometers in 6 hours. So total distance, speed, time. The unit for distance is given to us as kilometers. Speed will be kilometers divided by time, which is hours. Correct? So this is what it is. Condition, into wind. So in wind. When we say in wind, wind is coming from the opposite direction. Do you understand? So we're talking about two things here. Let's read and then we'll come back to this table. When it flies with the wind, it can travel the same distance in 5 hours, much lesser time, 1 hour less. Find the speed of plane in still air and speed of wind in still air. So this is what it is. So we'll define a variable. First thing, we'll say let P and W B, speed of plane and wind, right, in still air. I mean, is it okay? P, plane in still air. I hope you get the point, correct? Okay. So when we go into the wind, that means wind is coming against. It is slower, so it is P minus W. With wind, so that means wind is helping. So both, I'm sorry, I should have written speed, right? Both are helping, so it is P plus W. This is incorrect. Okay. Now let's talk about time. So it says 3000 kilometers in 6 hours. So we are given distance of 3000 kilometers and time is 6 hours. For the second condition, it is 3000 kilometers and the time is 5 hours. This is what we are given. We have to find these two speeds, plane and still air, right? Now that is what we are given. We are going to apply the formula distance is speed into time. Perfect. So we get two equations. The first one here, 3000 equals to, speed is P minus W, time is 6. Is it okay? Now we can simplify this. We can divide 3000 by 6. So 6 goes 5 times. We have 500 equals to P minus W. We get one equation. Let me call this as our equation number 1. Now the second equation comes from this statement, which is 3000 equals to P plus W, time taken is 5. Dividing 3000 by 5, I get 600 equals to P plus W. I will call this as my equation number 2. Perfect. Now we have to find P and W. Very simple. If I add them up, that is, if I add equation 1 and 2, what do I get? 500 plus 600 is 1100 equals to P plus P is 2P and minus W plus W is 0. So we get twice plane speed is 1100. So from here we get that the speed of the plane is half of 1100, which is 550, correct? And the units are kilometers per hour. So we could write down answer here as P equals to 550 kilometers per hour. Now let's do the second thing, which is this time, let me break this up. This time we will do equation 2 minus equation 1. Since this is a bigger number, that's a good idea, right? So if I do that, equation 2 minus equation 1, 600 take away 500 is just 100. And that is equal to W minus minus W twice W, or wind speed is 50. 500 divided by 2. So I can write this answer as 50 kilometers per hour. Do you see that? How simple it is. So we found two equations based on the two given conditions. One with the wind, one against wind, right? Whenever you go with wind, same direction, correct? Both are in the same direction. You add them up. In this case, it is against. So we had to subtract it. Does it make sense to you? Let's move on. Now here is question number 3. Now let us solve question number 3. It is 395 kilometers from Ski Valley to Vancouver. Sam made the trip in 6 hours, traveling by the bus and train. The train averaged 70 kilometers per hour and the bus 60 kilometers per hour. How much time was spent traveling by train? So let us write down all the information given to us. First, we'll make this distance time relationship, and then we'll make our table, right? So our table is given different situations. Those are the columns for different situations. And these three is distance, speed, and time. Perfect. So normally we'll write distance here, speed, and time. and that is for total. Correct? So let's see how to fill this up again. It is 395 kilometers from Ski Valley to Vancouver. This is total distance. So we'll write 395 here. Sam made the trip in 6 hours traveling by bus and train. So this is total time, 6 hours. Traveling by bus. So we'll write bus here and train. Is it okay? The train averaged 70 kilometers per hour. So that is the speed, 70. The units are kilometers per hour. And the bus 60 kilometers per hour. Okay, let me write down the units. Kilometers per hour, time is in hours. Perfect. Now it says, how much time was spent traveling by train? So let us now define our variable. Let this time be t. Now if that is the time by train, how much time by bus? 6 minus t. Is it okay? 6 is total time. So by bus, it will be 6 minus t. Once you get that, you know distance. Distance is speed into time, right? We have distance is speed into time. So we'll just multiply these two and can write here, which is 60 times 6 minus t, and this is 70 times t. Perfect. And total is 395. So from here, we get one equation. Do you see that? So the equation is 60 times 6 minus t plus 70t is equal to 395. So simple, right? That is how you should be doing such questions. Now, we can actually open this bracket, take the terms together, and then simplify. So 60 times 6 is 6 times 6 is 36. So we get 360 minus 60t plus 70t equals to 395. Correct? Now let's bring similar terms together, which is, well, we can simplify this first. So we'll do 360 plus 10t equals to 395. And then we can take this on the other side. So then we get 10t equals to 395 minus 360, right? So 10t is equals to, when you take away 5 and then 35, correct? So 35 you get. So t equals to 35 divided by 10, which is 3.5, correct? So time taken, how much time was spent traveling by train? The answer is 3.5 hours, or 3.5 hours. So we can write down our answer as time taken by train is 3.5 hours. Is it okay? So that is how it can be done very easily. Perfect. Now let's move on and see the next question. It says, when Lucy swims with current, she swims 18 kilometers in 2 hours. So this is a case when we are talking about swimming against current and with current. Is it okay? So it is that kind of a case. Just as we did by plane, against wind and with wind. It's very similar. You can actually pause the video and answer it similar to our first question. Okay, so it says, so we'll write distance, speed, time. Lucy swims with current. She swims 18 kilometers in 2 hours. So distance is 18 kilometers in 2 hours with current. So it is with current. So when you go with it, you add them up, right? So we say swim with, so we say Lucy's speed plus water speed. It adds up. Against the current, she can swim only 14 kilometers in same time. Same time means 2 hours. So 14 kilometers in 2 hours. Against means minus, right? So against. So Lucy's speed minus water current. Is it okay? That is two different equations, correct? Now, how fast can Lucy swim in still water? So in still water, let the speed be L. So we'll define our variables. L is Lucy in still water. Is it okay? And W is water current. You can write speed, but that is obvious. Now we have two different conditions here. Distance is speed into time. So in all my questions, I'm avoiding fractions. So this helps us write linear equations. So we get distance of 8 is speed of L plus W times time of 2 hours. We can simplify. Divide by 2. So we get 9 equals to L plus W, right? This is my equation number 1. Second equation. 14 equals to L minus W times 2. Divide, you get 7 equals to L minus W. This is my equation number 2. Now see, we'll get two conditions. One, we will do equation 1 plus 2, correct? In the second, we'll do equation 1 minus 2, okay? So if I add these up, 9 plus 7 is 16 equals to L plus L is 2L. So L is 16 divided by 2, which is 8. If I do 1 minus 2, I get 9 minus 7 as 2 equals to L minus L is 0. W minus minus W is 2W. So water speed is 1. Do you get that? So we get both the speed. So we can now write down the answer as Lucy's speed is 8 kilometers, include units, and water current is 1 kilometer per hour, right? So that is how it should be done. Fine. Let's move on to question number 5. Question number 5 is, Sonia took a 440 kilometer trip traveling by bus and train. The bus traveled 80 kilometers per hour and train traveled 100 kilometers per hour. The whole trip took 5 hours. How much time did Sonia spend in the bus and what distance she traveled by the train, right? So that is the question. Let's try to see the situation now. So we are talking about distance, speed and time. We are given two situations, one by bus, the other by train, right? So we're talking about bus and train. This is for total, right? And we know this is distance, this is speed and time. Units, we're talking about kilometers per hour, and time is in hours, correct? Now let's substitute all the values here. Fill in the table. Sonia took 440 kilometer trip traveling by bus and train. So both is 440. Is it okay? The bus traveled 80 kilometers per hour, train traveled 100. The whole trip took 5 hours, correct? How much time did Sonia spend? So time Sonia spent in bus. So we'll say this time we don't know. We'll write T for this. And what distance she traveled by train. So we don't know this distance. So this is what we have to figure out. Is that okay? Now from the given situation, if I say, so I'll define my variables, correct? So I'll say let T be the time Sonia spends in bus. In that case, what is the time in the train? Total is 5, right? So this has to be 5 minus T. Is it okay? Now distance is speed into time. So this distance can be written as 80T, and this distance will be written as 100 times 5 minus T. Does it make sense to you? Perfect. To get an equation, we already used this equation, right? When we write 5 minus T, we have this equation now to work with. So we know 80 times T plus 100 times 5 minus T is equal to total distance of 440. Perfect. Now we can simplify this equation, dividing everything first by, let's say 0, right? So we have 8T plus 10, we're dividing by 10, okay? 5 minus T equals to 44. We can still divide by 2, right? So we get 4T plus 5 times 5 minus T equals to 22. When calculator is not allowed, it is good to do these small steps, right? You could have done divide by 4 straight away, right? I mean, you could have, right? So why we did not divide by 4? Okay, 4 times 25. There's something wrong. So 10. So we could have divided by 4. Okay, because of this. Okay. Anyway, we did by 10 and then this. Fine. So this is what we get now. First we divide by 10, getting rid of these zeros. Okay, these zeros. And then we have divided by this equation by just 2, because 10 cannot be divided by 4. That's the reason. So we get our equation. Now let's open the bracket. So when you open the bracket, you get 4t plus 5 times 5 is 25 minus 5t equals to 22. Bring constants together, and here we have 4t minus 5t, so it is minus t equals to 22 minus 25. So we have minus t equals to minus 3, t equals to 3. So we know t is 3. Therefore, once we have t is 3, we know train distance also. Do you see that? So we can write down our answer. That is, how much time did Sonia spend in bus? So time t. Time spent in bus is 3 hours. Is it okay? So if this is 3 hours, how much is this? Then what distance she traveled by train? So distance by train, we are talking about this distance, is 100 times 5 minus 3. 5 minus 3 is 2. So we get 200. And the units are kilometers. Do you see that? So that is how you're going to find your answer. Perfect. Let's move on to question number 6 now. A duck can fly 2400 meters in 10 minutes with the wind. Against the wind, it can fly only 2/3 of this distance in 10 minutes. How fast can the duck fly in still air? What is the speed of the wind? So let's make our table once again. So you see how similar all are, correct? So it's not difficult at all. Okay. Distance, speed, and time. So we are talking about with wind, that means both are going in the same direction, correct? We have here distance, speed, and time. Units for distance here are meters. See, meters. Time is in minutes. So speed will be meters per minute. Be careful about this part, correct? Now it says, duck can fly 2400 meters in 10 minutes with wind. So both same direction, correct? If same direction, then their speed add up, right? So duck plus wind. Distance is 2400 meters. Time is 10 minutes. Against wind, it is kind of like this. Do you understand? So we are saying this is duck and this is wind. This is duck and this is wind. Wind is going against, so the equation will be d minus w. Against wind, 2/3 of the distance. So 2/3 of 2400. Do you understand? 2/3 lesser distance in the same time, right? 2/3 distance, 10 minutes. So you get two equations. Perfect. We'll write always equations in product. Distance is speed into time. So from the first equation, we get 2400 equals to d plus w times 10. We can simplify. Divide by 10. We get 240 equals to d plus w. Second is 2/3 of 2400 equals to d minus w times 10, right? Divide by 10. So we get 2/3 of 240 equals to d minus w, right? So you can simplify this. When you divide by 3, what do you get? 3 goes 8 times, 80. So now you can multiply by 2 and you get 160 is equals to d minus w. So we get two equations. I'll call this as equation 1, this as equation 2, right? And then we'll do the needful. So we'll add these two up, equation 1 plus equation 2, and we'll subtract one from the other, always from plus to minus, that is better, right? So if I add them up, I get 240 plus 160, so add them, 0, 6 and 4, 10, 2, 1, 3 and 1, 400 is equals to twice d, or d is 400 divided by 2, which is 200. Is that okay? On the other hand, if I take away 240, take away 160 is 0, take away 0 is 0. 14 take away 6 is 8. 4 plus 4, 8. And we borrowed already, is equals to twice wind speed, or 80 divided by 2 is wind speed, which is 40. Correct? What are the units for you? Meters per minute. Don't forget that. Meters per minute. So here, meters per minute. Is it okay? So now you should write your answer. What is the speed of the wind and how fast duck fly in the air? So our answer is, for duck, it is 200 meters per minute, and for wind, it is 40 meters per minute. Perfect. So that is how it should be solved. Now let's move on to question number 7. Question number 7 is, from his home in Point Alexander, Dan drove to Belleville at an average speed of 75 kilometers per hour. From her home in Chalk River, Ashley drove through Alexander to Belleville at an average speed of 85 kilometers per hour. The distance from Chalk River to Alexander is 18 kilometers. If Dan and Ashley left home at the same time, after what length of time did Ashley overtake Dan, right? So that's the question for you. Now this is slightly different from what we had been doing so far. So let's kind of sketch our diagram and understand. So let's say this is from Alexander to Belleville. This is where Dan drove at a speed of 75 kilometers per hour. Correct? Now, Ashley actually starts from a different place, Chalk River, and goes via this. So let's say Chalk River is somewhere here, right? So first she covers this distance and then she goes along the same path. So we'll call this as C. Now what are we given about this portion? It says Ashley drove through Alexander to Belleville at the average speed of 85 kilometers per hour. So for her, the speed is 85 kilometers per hour, right? So that's much faster. The distance from Chalk River to Alexander is 18 kilometers. So this distance is 18 kilometers. So what we're trying to say here is this is extra distance she has to cover, right? If Dan and Ashley left home at the same time, after what length of time did Ashley overtake Dan, correct? Since they started at the same time, let's say time starts now, t, right? After what time they reach the same distance? That is what the real question is. Let's say they reach the same distance here. So in that case, Ashley will cover that much of distance and Dan will actually cover only this much of distance. Do you see that? But they will take the same time. So we'll define our variable as let the time be t hours. Is it okay? Now, distance is speed into time. We know distance is speed into time. Perfect. That's the triangle. So we can now write down the equation, that is the distance traveled by both will be like if you see, this distance will be 18 plus that much. So distance traveled by Ashley, so we can say distance by Ashley is equal to 18 plus distance traveled by Dan, correct? So that is 18 plus distance traveled by Dan, because Dan travels only from A to B. Perfect. Now what is the distance traveled by Ashley? 85 kilometers per hour in T hours, right? So that gives you one equation, which is 85T, and that is 18 plus distance traveled by Dan is 75 kilometers per hour in T hours. So that is the equation. Perfect. Now we have to only solve this equation. So let's bring it on the left side. So we get 85T minus 75T equals to 18. And that is 10T equals to 18. And that gives you T is equals to 18 divided by 10, which is 1.8 hours. Do you see that? So that is how you could easily find the time when Ashley overtakes Dan, right? So the question was, if Dan and Ashley left home at the same time, after what length of time did Ashley overtake Dan? So our answer is after 1.8 hours, right? So that is how you're going to answer this. So this is not that difficult, but you have to understand, like this figure helps you to understand. Perfect. Let's move on to the last question, which is question number 8. Question number 8 is, a salmon swims 100 meters in 8 minutes downstream. Upstream, it would take the fish 20 minutes to swim the same distance. What is the speed of salmon in still water? What is the speed of the current, right? So again, we have a very similar question, upstream, downstream. That means we are traveling with water current and we are traveling against water current, correct? So let us say this is with water current, correct? And this is against water current. So we are talking about salmon, which is a fish. So when it goes with, let's say salmon is S and current is C, right? When against, let me just first make these 3 columns, speed, distance, time, and then we'll fill it up, right? So we have this as distance, speed, and time. Units, meters, and minute. Do you see that? So distance is in meters, time is in minutes. So speed is meters per minute. Perfect. So salmon swims 100 meters in 8 minutes downstream. That means along same distance, same direction. So 100 meters in 8 minutes. And when they go in the same direction, their speed add up, right? So it is salmon plus current. Upstream, it would take the fish 20 minutes to swim the same distance. So distance is again 100. This will be take away, and this time taken will not be 8 but 20. Correct? So that gives you 2 equations. We know distance is speed times time. So those are the 2 equations. So first equation we'll write here as 100 is speed is S plus C times 8. The other one is, we could simplify this, correct? So dividing both by 4, we can divide both by 4, right? So you get 25 is S plus C times 8. We can open this, we get 25 equals to 8S plus 8C, correct? The second one, we have 100 equals to S minus C times 20. Dividing by 20, we get 5 equals to S minus C. Correct? So we have, we divide by 4. This should have been 4. 4 times 2 is, right? This should be 2. I'm sorry. We divided both by 4, right? So when you divide 8 by 4, you get 2, twice. Okay. So we get 25 is 2S plus 2C. And here we get 5 is S minus C, right? So we could do with substitution, or we could solve it by elimination. Since these are 2's, let me multiply this by 2. So I get 10 equals to 2s minus 2c. Does it make sense? So we'll call this as equation 1, this as equation 2, and we'll actually do our pattern the same way. So we'll do equation 1 plus equation 2 and equation 1 minus equation 2. So if I add them up, 25 plus 10 is 35 equals to 2s plus 2s is 4s. Is it okay? So s is 35 divided by 4. On the other hand, if I take away 25, take away 10 is 15, and that 15 is 2c, take away 2c is 4c. So c is 15 over 4, correct? So that is what their speed is. So we can now write down our answer, that is salmon speed is, you could either write like this or mixed numbers. 35, 4 times 8 is 32, so 8, 32, remainder is 3 over 4. Units are for speed meters per minute, and for current, that is water current, it is 15 over 4. 4 goes 3 times, and you get remainder 3 over 4 meters per minute, correct? So I hope you understand what I'm doing here. I'm just dividing 15 by 4, right? So 15 divided by 4, which 3 times is 12, and remainder is 3. So I get this 3 here and the remainder there, perfect. And on the other side, I did 35 divided by 4. 4 times 8 is 32, and the remainder is 3. So I got 8, 3 over 4. So that is how actually you could solve all these questions. Well, I answered all these questions, most of them, using a single variable. However, if you want to do them with 2 variables, you could do as we did some of them, perfect. It is important to recall that first step should be to define your variables. In later half, I did not write the let statement. You have to always write the let statement saying, in this case you will say, let the speed of salmon in still water be s, and let the speed of water current be c. And then you begin forming all these things and your equations. Solve your equations carefully, avoiding such mistakes, and get your answer. So I hope you enjoyed the whole journey. It should be now very simple for you to solve word problems based on distance and speed. Thanks for watching. If you like and subscribe, that will be good for me. Thank you, and all the best.